Hey guys, Mrs. O'Donnell here. Today we are continuing with multiplying polynomials and we're going to investigate some special products. Our goal for today is to develop procedural fluency multiplying special cases of binomials. Our agenda is posted here. It's also in Google Classroom. If you are struggling, I hope that you will come to office hours and get some help. All right. These are some really great problems. If you want to take a minute, pause the video and try some of these out, you can. But due to the sake of time, we're going to push ahead. So first of all, we've got this warm up and we're going to use this opportunity to kind of refresh what we were working on last week, which was multiplying our polynomials using our box method. Okay, so if you feel confident with the box method, you can go ahead and pause the video now, give these a try, and then unpause to sort of check your answers. All right. Factored form is when you see these two factors, so it's before you've done the multiplying. And standard form of our quadratic or of our polynomial is really just when you see everything has already been multiplied out, right? You just see that actual polynomial expression. All right, so if I'm going to do my x minus 3 times x minus 5, I'm going to start out by making my box. I don't have like a ton of room here. X minus 3 and x minus 5. And it doesn't matter which side you use for your area model. You could have made the vertical side x minus 3 and the horizontal side x minus 5. Does not matter, okay? And then go ahead and do that multiplication, right? X times x gives me x squared. Negative 3 times x is negative 3x. X times negative 5 is negative 5x, and negative 3 times negative 5 gives me a positive 15. So my final polynomial would be x squared. I've got a minus 3x and a minus 5x. I know those are like terms. So negative 3 plus negative 5 gives me a negative 8 or a minus 8x plus 15. All right, so I'm going to go ahead and fill that in. X squared minus 8x plus 15. All right, and then let's see here. I could go ahead and do my next one. So this one's pretty straightforward. You might even just try this problem using distribution. I'm going to show you guys what this looks like using an area model just because we're practicing and we're learning. Okay, so let's see here. I would do x times x to get x squared and x times negative 5, which gives me negative 5x. So my polynomial is x squared minus 5x. Easy enough. You could have just done the distributive property as well, right? X times x times negative 5. This next one, they're asking us to factor, go from standard form to factored form, which we haven't learned yet. So for right now, I'm going to skip that and we'll come back to it. Down at the bottom here, we have we have a little bit more complicated of a binomial times a binomial. So let's go ahead and we'll make our box. I've got a little room, so I'm going to make a bigger box. And I'm going to do 2x plus 3 and x plus 6. And go ahead and multiply to see what your final polynomial is. So 2x times x is 2x squared. 3 times x is 3x. 2x times 6 gives me 12x. And 3 times 6, that's going to give me 18. All right, so I'm going to combine my like terms. So I've got 2x squared, 12x, and 3x. That's going to give me 15x plus 18. So I've got 2x squared plus 15x plus 18. All right, so you might be noticing a couple of patterns, right? One pattern that you might notice is this diagonal, okay, is typically giving us like terms that we can combine. So that's something to pay attention to there. You may also be noticing that with most of our polynomials that we're multiplying, that we're getting sort of an x squared term and then a constant term on the other diagonal, an x squared and a constant. Now that really depends a lot on what your factor pairs are that you're multiplying. It may not necessarily always work out so nicely, but those are some patterns that might help us kind of if we keep them in the back of our mind as we work through. All right, so then let's see if we can work through this x squared plus 6x plus 5. Okay, so if we do an area model for it, right, we know that we've got our x squared. We know our diagonal is going to add to make 6x, and we know that this last term is 5. So in order to multiply to make x squared, I have to have an x and an x. And then factors that multiply to make 5 would just be 1 and 5. And we want to think, okay, if I multiply 1 and x, I'm going to get 1x, and 5 and x, I'm going to get 5x, and if I add those, I get 6x. Well, hey, that tells me that I've got x plus 1, x plus 5. We could kind of work our way backwards through it. All right, so now we're going to do a little bit of an exploration. It says, look at the expressions in the table below. What do you notice? All right, so again, this would be a good time to pause the video. You could write down some things that you notice and then try multiplying them out using the box method. Maybe think of a few more things that you notice. And, you know, it's a lot of problems. Is there a shortcut that you found you were able to come up with? All right, so the first thing that I notice is that I have perfect squares in all of my boxes, right? X plus 1 times x plus 1 is the same thing as x plus 1 squared. X plus 2 times x plus 2, that's the same thing as x plus 2 squared. X plus 3 times x plus 3 is the same thing as x plus 3 squared, right? X plus 5 times x plus 5, that's the same thing as x plus 5 squared. X minus 1 times x minus 1 is x minus 1 squared. X minus 2 times x minus 2 is x minus 2 squared. X minus 3 times x minus 3 is x minus 3 squared. X minus 5 times x minus 5 is x minus 5 squared. All right, so now what we want to do, so I notice that I have perfect squares. I notice I have addition on the left and subtraction on the right. In the right-hand column. And the next thing I want to do is just go through and actually do my multiplication, right? So if I get my box method going, and I've got x and 1 and x and 1, right? So I'm going to do x times x, which is x squared, 1 times x, which is 1x, x times 1, which is 1x, and 1 times 1, which is 1. I end up with x squared plus 2x plus 1. All right, and then let's see here. Let's do the same thing with our next one. Right, so I've got x and 2 and x and 2. So I end up with x times x is x squared, 2 times x is 2x, 2 times x is 2x, 2 times 2 is 4. So I've got x squared plus 4x plus 4. All right, let's do another one. Let's see here. So I've got x plus 3, x plus 3. So x times x is x squared, 3 times x is 3x, x times 3 is 3x, 3 times 3 is 9. So I've got x squared plus 3x, and 3x makes 6x plus 9. All right, and let's see here. Let's do another one. Last one on this side. So I've got x plus 5 and x plus 5. So x times x is x squared. 5 times x is 5x. X times 5 is 5x. And 5 times 5 is, nope, I don't know why I just did that. 5 times 5 is 25. Oh man, it's late and I'm tired. So we've got x squared plus 10x plus 25. All right, so at this point, you might be starting to see the pattern. Okay, hopefully what you're starting to see is that the first term is squared, the last term is squared, and then the middle term is 2 times the first times the last, right? So we've got, if we had a plus b squared, we would have a squared plus 2ab plus b squared, right? So let's see if that holds true over here, okay? And let's see here. We'll grab our little, make our box. We've got x minus 1, x minus 1. X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is negative 1x. Negative 1 times negative 1 is positive 1. So I've got x squared minus 2x plus 1. Okay, so already it's not consistent with the same pattern, right? If I have a minus b squared, now my pattern is a squared minus 2ab plus b squared. All right, so let's see if that pattern holds true with some of our other problems. Let's see here. So here we've got x minus 2, x minus 2. So x times x is x squared. Negative 2 times x is negative 2x. X times negative 2 is negative 2x. Negative 2 times negative 2 is positive 4. That gives me x squared minus 4x plus 4. So far, so good. Let's do another one. Let's do, so we've got x minus 3, x minus 3. X times x is x squared. Negative 3 times x is negative 3x. X times negative 3 is negative 3x. Negative 3 times negative 3 is positive 9. So that gives me x squared minus 6x plus 9. All right, so let's see if we can do this last one just by using our pattern, right? So if we're just using our pattern, let's see here, we would have x squared, and let's see here, our last term would be 5 times 5, which is 25. And then we're going to do 2 times the first term times the last term. But I want to make sure I use a minus sign in there. So I'm going to change that to a minus. So 2 times x times 5. Let's see here. 5 times 2 is 10, so negative 10x. All right, so really these key patterns, you can continue to use your box method to multiply them out, but something that might help you move a little more quickly through multiplying your perfect squares is being able to recognize those patterns. Okay, so our shortcuts that we had a plus b squared was a squared plus 2ab plus b squared. And then we also had the pattern a minus b squared equals a squared minus 2ab plus b squared. So the key difference between them, the one on the left has plus signs and all plus signs in the polynomial once it's multiplied. The one on the right has a minus sign, and then it has this one minus sign before that middle term when it's being multiplied. So for answering these questions, will your shortcut work for x plus 1 times x plus 2? How do you know? No, it will not work because it's not a perfect square. Okay. Will your shortcut work for 2x plus 1 squared? How do you know? Yes, it will work, but we'll have to be cautious with that 2x because that entire 2x is that a term. So it will work, but we have to be cautious. And we know it works because it's a perfect square, and this works for all of our perfect squares. Next, will your shortcut work for x squared plus 3 times x squared plus 3? How do you know? Yes, because we can write that as x squared plus 3 squared, so it is a perfect square, but again, we have to be cautious with that x squared term. That's that a term. All right, will your shortcut work for this x squared minus 15x squared plus 30? Again, right here, what you want to look at, First of all, x squared minus 15x gives us negative 14x squared plus 30. And we see we do not have a perfect square right there, so no, it will not work. All right, stay tuned. I'm going to have to do a part 2.